Hi there, Frank Tate here again, and today's video is on using XSL in an XSL transform to convert ISIM audit data from the ISIM database, XML, into more visually appealing HTML. So to understand this, you're going to need to know ISIM, of course, be somewhat familiar with the audit data in the ISIM database, and also be familiar with XSL. I'll walk through each one of those a little bit, but if you don't have all of that background, you might be a little bit lost. So I'm just going to jump right in, and I'm going to show you what ISIM audit data looks like. And I'm going to scroll up a little bit. There we go. The audit data from an ISIM reconciliation looks like this XML. And the tricky part here is what you'll have in the first part. Well, you have an object element, one object element. That's the top part of the XML. And what it doesn't have is these first two lines that are normally required for syntactically correct XML, but they're not necessarily required depending on which XSLT processor you're using, and I'll talk about that a little bit more. But just the data that comes out of the database is this guy. So there's one object element, and in there you have multiple attribute elements. And these attributes show up in the GUI when you're looking at the audit from a reconciliation, where you look at the entity. And it will show you the values that have come in, the current values for the entity, and the new values that have come in on the reconciliation, or updated values, new values, and any removed attributes. And so what you'll have here in the list is the attributes that already exist in the entity, in the person. And here we have two of them. We have title and Acme Groups. My company name is Acme. And then we have the replacements, so the changes, if there are any, then any removals, any attributes that are being wiped out, basically, set to null, and any attributes that are being added by this reconciliation. So inside a change or replace type operation, what you'll have is an attribute with a name, attribute change operation. That's the same for all three of these. And then inside it, you'll have an object element with a name of attribute change operation.operation.replace. For remove, it's .remove. For add, it's .add. That'll be extremely important in our XSL. And then we have the name of the attribute that's been changed, or whose value is being replaced here. And so it's Acme Groups is being replaced with new values. There are three scalar values here. And then we have the remove, which is easier because all you've got is the name of the attribute. There's no value because it's being removed. And then we have the add operation, where we have a new attribute that's not in the original list. And we have it listed here in this list of attributes, and its list of scalar values. So what my whole goal was to turn this XML into this HTML so that it's just easier to view. And so what that looks like is this, basically, where we just need to I needed to put some stuff in a table and to highlight any changes additions or removals. And I also wanted to sort the attributes because in the XML, it's just not sorted. So we're going to take a look at the XSL I have created to do this. And we're going to look at it and compare it to the XML that we have. So let's see, we will, we'll zoom in on the XSL and see what we have, and then try to explain how I came up with what this is doing. Let's see, so it's a little bit long. Yeah, we're zooming in. I'll zoom out so that we can look at how it compares to the XML in a little bit. But this is the style sheet. XSL, like XML, can be a little bit wordy, so it's a little bit painful. But the big problem I needed to solve here is in the XML. So I'm going to go back to the XML here. In the XML, what I want to show in the HTML is I want to show the attribute name, and the big one that's a challenge is I want to show the current value and then the new value. Now notice in the XML we have this stuff in different parts of the XML. So for Acme groups, I have that's been changed. I have Acme groups first, and then later in the XML, I have the new value for it. And I need to make sure to get exactly this value in the attribute change operation.replace object element. And that was really the big challenge. And so I'm going to go and show them side by side, the XML and XSL, and go through a little bit about what I was doing. So first line is to strip any spaces from, or unneeded spaces from, the elements. No big deal there. And then what I want to do is match that top level object element. So I want to match this guy in its entirety, basically. So this is my main template doing that. And so I'm laying out the HTML and the body table, and then the header row of the table, and then specifying that I want to apply the templates for the children inside the slash object element. So that's what I have here, where I'm telling it to apply the following templates to the children of objects. So I'm going to apply the remaining templates to all of these children. Now, what I'm also specifying as an option to this apply templates function is I'm telling it to sort the list of child elements by the name attribute. So I am sorting by this name. So it's really Acme groups title, Acme groups, and we'll also have Acme position number in here. But basically sorting those alphabetically. And if we look at the output, we do see Acme groups, Acme position number, and title in here alphabetically. So then I get to the templates themselves, and this is the big one that took me a while to come up with, and that's the whole reason why I wanted to put this out there to help other people. But there is one big template match for attribute elements that are children of object. Now, here's where we really get into XPath, where in this case, I'm using a predicate on the child attribute object. So I'm currently inside, when this template is being evaluated, I'm inside /object. So I'm looking at an attribute or a child element named attribute. And then I'm specifying with this predicate that I only want to find these attribute elements that don't have an object child. So I want to exclude these guys because these guys all have a child object. I also found out that I needed to exclude any elements that have a great grandparent. And what that means is to exclude these. Otherwise, at least in this processor, this XSLT processor, and I'll talk a little bit about that in a second, it was also applying this template to these embedded attribute objects, and I needed to exclude them. So the way I did that was with this with this predicate applied to this XPath expression. So the XSLT processor I'm using here is Visual Studio Professional, and you can get a license for this for $5 these days. So there's no reason not to. And the reason I'm using it is it has this neat little option for XSLT debugging, which is an absolute lifesaver, and you have to use it. If you're dealing with XSL at all, you want to use something with a debugger. I tried using VS Code, and I couldn't get the XSLT debugger extension to work. But Visual Studio itself, Visual Studio Professional, it just comes with it out of the box. Easiest thing in the world, and it's just wonderful. It's much easier than just trying to run an XSL transform within a browser, because in the browser, none of the browser engines will actually support the XSL message function, which can be used to print out debug messages. There is on Linux, there's XSLT proc, a command line tool that will actually print out debug messages using the XSL message function. But from a Windows perspective, just using Visual Studio Professional is easy and just a super lifesaver. So in using the XSL processor that's in MS Edge or Google Chrome, for example, you don't need this extra predicate to exclude these embedded attribute elements, but within Visual Studio Professional, you do need it. So the next thing in here is what I want to find is I'm going for, in this particular template, I'm looking for replace or remove, because those are the tricky ones, because I need to, if I'm removing it, I need to, after the fact, set my row to be red highlighted. If I'm replacing it, I need it after the fact, after I find the attribute the first time, I need to highlight it as green, and I need to include the new attribute values. So what I have is an XSL choose, which is like a case, or it basically replaces the if statement in XSL. And so I'm going to have two when options and an otherwise inside this choose. And the first one is I'm looking for any replace for the current attribute that I'm looking at. And I need to match it up with the same name. So this gets a little bit tricky. So when I'm looking in, when this template is being applied to the attribute name Acme Groups. What I'm doing is actually first I am setting a variable named current name, and what I'm selecting is the value of the name attribute. So of the current element. So the value of the name attribute is Acme Groups. There is also in XSL a current open paren, close paren function, but it's not supported. It happens not to be supported by the XSLT debugger in Visual Studio, which is just crazy. It's supported by the XSLT processor, but not by the debugger. So if you have it in there and try to debug, it craps out, basically. So to get around that and to work in all cases, I just went with setting a variable instead of using the current function. So what I want to test is I am going to go through and look for all elements that match this XPath expression. And there should only be one. And the expression is, so I want to go up a level. So I'm currently inside, basically inside here. I'm inside this element. So for this search, I'm going up one level, so to the object element, and I'm looking for any attribute child that has, I'm up here. Any attribute child that has an object child whose name attribute contains the word replace. So I am looking specifically for this guy, so which is a child of an attribute, it's an object, and its name attribute contains the word replace. So I'm in there, I'm good. The next thing I'm testing for in this XPath expression is that object element further has an attribute child whose name is the same as the current name attribute. So this guy that was set up here. So I'm looking for an attribute with a child object whose name contains replace that has an attribute child whose name is the same as the name of the element that we're currently analyzing. And I know that's confusing. That's just tough. Hopefully you can replay this and understand what all that means if you don't already. So once I find that, and I only have one of those, what I'm going to do is perform these operations or spit out this data for each one of the elements that matches this XPath expression. There's only one of them. And so what I'm going to output is a new table row and then an XSL message just for debugging. This isn't required. And then I'm going to call a template, have a typo in there, but I'm going to call a template named TDTD to write stuff out. And what I have there is the TDTD template is this guy that's being called directly. So what it's going to do is it's writing out one table element or a cell with the name of the attribute. So it's writing out Acme Groups, this one that we're looking at. And then it's calling the multiscalar template in case there are multiple values. So I had to figure this out also. And this multiscalar template goes through and it creates a table cell. And what it does is it goes through each of the scalar attributes for this guy. So it's going to go through at this one for the element that we're analyzing. It's going to go through and just grab group 1, the name group 1. Another thing I did in here is actually the values have really long values. And so what I'm doing is cutting off the existing values at 20 characters and replacing the rest of it with ellipses. So I'm saying if this scalar value, and again it's under this original element that we're analyzing, if this value is longer than 20 characters, then what I want to do is strip off the first 20 characters, and I want to keep the first 20 characters and remove the remaining characters and just replace them with ellipses. Easy enough. And so it's going to loop through all of those, but for right now, it's just got one value. And looking back at the output, there's just this one value. So we're going to go back to the processing that's going on. So we did the call template TD. That created 2 cells here. It created this one and this one. It set the background as yellow. That's what we have here. And it output these first 2 cells. Then we are outputting another cell, table cell, and here we're doing another for each, but now we are going and grabbing that matched element, basically, that we had up here. And so we are selecting, so we're going up 1, we're going to find the attribute containing the object that has an attribute whose name equals current name, and we're going to grab each one of those scalar values and strip off any extraneous space that we don't need and put a break at the end of it. So we're going to go through and find basically the sibling attribute object with attribute element with an object child that has an attribute child whose name is Acme Groups, and we're going to loop through the scalar values. So we're going to loop through all of these and print them out inside with a line break after each one inside a single cell. And that's what we've done here, and that's just my little typo that I am going to fix right now. Just go through it here and start XSLT without debugging. It will run the debugger. There we go. So we've got this stuff. So that's the first win statement. The second one is a little bit easier. It's for a removed attribute. So it's much easier. All this guy has to do is print out a table cell with the value of the current attribute, and then a table cell with the word removed. This is easy. But again, still what's required is finding that it is actually removed. So we're looking at this attribute, and then we're needing to look for essentially a sibling attribute element with an object child that contains the name remove, that has an attribute child whose name is the same as the current name. And then otherwise, we're just calling the attribute TD and ending it. So it's going to do nothing essentially for anything else that it happens to match. And there shouldn't be anything else to match. What do we have? Template, attribute, not object. It won't match anything else. We're going to come down here, and the next template is just what we looked at before, the TD template, and then multi-scalar that we also showed before. Then I have just a template named removed, and what this is doing is the XSLT processor in Visual Studio requires there to be a template batch for everything, essentially. So I had to do this for the processor within Chrome or Edge or Firefox. You don't need to do this, but I just wanted to make sure that for the remove child element, that it's just doing nothing when it sees this guy. Yeah, I just needed to put that in there because the default XSL templates included in the processor were just messing with me. But then what do we have? The next thing is, I also needed to add this dummy scalar match, because again, this processor inside Visual Studio was matching these guys automatically and printing out some weird stuff. But that's the deal. And like I said, I'll have a link to the GitHub repository that contains this data. And hopefully you can do something with this. If you put it in the code, you'll need to put it in a for loop or some sort of loop to process this audit data for each entry that's found, or each person that's returned from the reconciliation or whatever you're looking at in the database. But I appreciate your time, and hopefully you got a whole lot out of this, and I'll see you next time.